What I'm planning now to introduce you to is the various phases of how we finally came to the design and development and finally the launch of the Apollo program. The propulsion systems were extremely important. This represents, if you will, the original stack. This is the system that took the Apollo into orbit and to the moon and returned. This is a very critical design aspect, because we, up until that time, didn't have any propulsion systems that could launch a spacecraft of the size that we originally anticipated. However, evolutionary came to be, and we found an awful lot of technologies available to us, and that was our space launch system. Coming down to some of the very early launches of the Mercury capsule. This was flown by a gentleman by one of the earlier astronauts, Alan Shepard. This was an orbital flight, and later the second Mercury flight was flown by my very dear friend Gordon Cooper. He flew in this particular, and now you recognize the design of the blunt front end of the capsule. And this is what we eventually adopt on the Apollo program. This is another a view of the Mercury capsule, and this was again an orbital test vehicle, and then here we continue on to the Gemini. The Gemini capsule again was launched back in the early 60s. This was Frank Borman was a crew member here. And again, there were two in this capsule. Jim Lovell was also one of the astronauts on this particular vehicle. Again, we have the rounded bottom, as you see. That particular concept eventually found its way into designing the Apollo system. This vehicle was designed by, again, the company I worked for, North American Aviation. Actually, it was a vehicle was designed specifically to bring the astronauts back safely and land on the ground. As you can see, there are wheels on this. They had an opportunity to actually navigate on the ground. That huge parachute up there is called a paraglider. This was a system was to have been developed and used and moved to rescue, if you will, the Apollo program upon its re-entry. However, NASA decided against it, and they went for a splashdown into the ocean. They recognized it to be much more safer rather than take a chance of a landing on the Earth. In the event that for some atmospheric conditions or situations where we missed a runway or we missed the landing site, and could well have created problems for this particular system. Now here's the Apollo spacecraft with all of its various boilerplate. On the bottom is what I mentioned earlier, they've gone to an ablative material to deflect an awful lot of the heat. Again, the round bottom reduced, if you will, the friction and the heat, as well as reduce the sonic booming of re-entry. What you see in and around here are the floating devices and the floating devices and the parachutes. Upon re-entry, the spacecraft will splash down into the ocean, and these floating devices will see to it that it remains afloat until the rescue ship finally picks up the astronauts. One of the things that I mentioned earlier, specifically as it pertains to one of my colleagues, Danilo Bojic, Danilo is responsible for having redesigned that emergency escape hatch. So we have been very instrumental, all of us on the 007 team, in providing support to this effort that successfully found its way onto the moon. Again, you can see the size of the vehicle. as many times that of what you've seen in the earlier systems that were designed for one individual or two individuals. We have 3 astronauts here. In this case, in the Apollo 11, we had Neil Armstrong, Buzz Aldrin, and Michael Collins. So this is the Apollo in its entirety, to include its splashdown capability.